Hey, so we should be live. If you can hear us, say where you are coming from in the world in the chat. I'm going to say where I'm coming from. So type in your city, country, your general region, your time zone if you'd like instead. All right, excellent. So it sounds like people can hear us. Cool, there's folks from all over the place. Okay, so let's get started here. First, I believe there are a lot of folks who probably haven't seen Weekly Python Chat before, and I don't know if I've ever really said what Weekly Python Chat is on a video. So for those who are new, Weekly Python Chat is a thing I do every week. Sometimes on my own, I teach a Python-related concept, or we just chat about something. Sometimes, probably about half the time now, I bring in a friend, an internet friend, someone I've met in real life, someone I've never met before maybe, to talk about something. Sometimes we chat about a thing that's Python related, sometimes something totally not Python related, and sometimes we show off some code or teach something. This chat is with Kevin. Kevin Markham, I met you.
Yes.
Let's see, we met each other through the internet. I think you signed up for my email list and responded to my welcome email, which is awesome because welcome emails are one of those things. People who have mailing lists who send you an email that says, I would like you to talk to me. It is the coolest feeling when someone responds to you and actually says something because you're like meeting a real person over the internet that way. So I was really happy to chat with you over email. And then we both found out we were going to be at PyCon.
Yep.
We both do some kind of teaching stuff. We both do things on the internet. So it was really cool to meet you in person at PyCon. So if you've got anything to add there, maybe I lied a little bit about that introduction. Add something else, but I'd like you to introduce yourself.
Yeah, no, thanks. First, thanks so much for having me, Trey. This is going to be really fun. Looking forward to it, and looking forward to trying out Crowdcast. Seems like a neat way to interact with folks and the chat and the video and all that. So really appreciate you having me on here. So myself, I'm the founder of Data School. And in Data School, I make videos and tutorials and blog posts and such about data science. Very focused on Python these days. I also run some online courses. My background is in computer engineering, and I spent a lot of time as a data science classroom instructor. Really love teaching and love Python, love data science. Classroom is really fun, but I like to reach more people, people that don't live in Washington, D.C., where I live. So that's why I started putting together a lot of things for online. And overall, my goal is just make data science more accessible to kind of the rest of us, if you will. So those without PhDs or deep mathematical backgrounds or a lot of specialized domain knowledge, how do we make data science accessible? So that's kind of my goal. And just personal, let's see, my birthday was a couple weeks ago, just turned 36. I live in Washington, D.C. And a couple weeks ago, I also just got married. So that was pretty exciting. And yeah, so been a busy summer is what it's been. So cool. Thank you. Thank you.
Awesome. Congratulations. So you, I guess I've never really introduced myself before. For people who don't know, I usually get paid to do training in person. I used to do consulting. Now I do training mostly for companies on site. So I like doing this online, mostly for free right now, just chatting with people online. It's really fun to both teach people and learn from people. I make most of my money from on-site training. You have been successful enough to make your living off of teaching people around the world through the internet, it sounds like. Is that what you're
I'm just doing Data School. That is all I am doing, because everything, if I found that when I was, even when I was just doing classroom instruction, certainly certainly that helped with a lot of kind of my practice for instructing and for thinking through how to teach things and try out different ways of teaching. But the only way I can put out a ton of free content, high quality content, and also create courses that cost money, such that I can actually make a living. The only way I can do that is full time. So that's why I'm focused full time on data school, which has been really, really fun. So,
yep.
Yeah.
In the chat, if you scroll up a little
should we
bit,
jump
I
into?
put a link to data school.
Oh, sorry. Good.
Yes. If anyone does have AV difficulties, I guess let us know in the chat. Unfortunately, it's hard to tell when Crowdcast is hiccuping for everyone or when it's just for you. Refresh the page if you have a trouble. I saw a couple people saying they had difficulties in the chat. Kevin, I want to let you take it away now. I know you've got some stuff prepared that you want to teach us, and then we'll go to Q&A afterwards. So
cool.
Go for it.
Cool. So I'll just give a brief introduction of today, and then I'll tell you when I'm ready with my screen, Trey. So my the first part will be pretty structured. My agenda is simple in terms of topics. Number one, I want to talk about like what is machine learning and how does it work. And some of you will already know that. If you don't, it's fine because I'm not presuming any understanding of machine learning. And the second is we're going to build a machine learning model in Python using the scikit-learn library. And I will be doing the code, and you are welcome to code with me or not. Totally up to you. I would encourage you to ask questions throughout. And then what would you say about the best way to ask questions, Trey? Is it the chat or below, or what's the, how should that go?
Below there is a big orange button that says ask a question or suggest a topic. If you could click on that to ask your question or suggest a topic, or even cooler if you said, look, I'm trying to solve a specific problem, something that's really my own thing. If you could give me a little bit of feedback on that, maybe, especially if you're new to machine learning. I notice a lot of the questions are pretty advanced questions. Do not be intimidated to ask a question if you're new to machine learning. A lot of us are. I know very little about machine learning, so if you could ask questions on my behalf, that would be awesome. So scroll down below the video, click that big orange button for questions. During your spiel here, Kevin, when you're teaching us, if everyone could, if you have something, a reaction that's in real time, feel free to throw that in the chat. The only problem with asking questions in the chat is it's going to get lost as everyone's seeing it scrolling pretty quick. So scroll down below the video to ask your questions.
Cool. That sounds good. So do ask questions throughout. I will answer a lot of the questions at the end. And as Trey said, a lot of the ones below the video that have already been asked are on the more advanced side. And I can't really answer those without kind of building a common framework that we're working off of. So I want you to understand the basics so that when I answer a question about it, you'll have more context. So a lot of those I will answer at the end. So let me go ahead and put my screen on screen, if you would, Trey. And maybe I need to click it again here.
All right.
I did. Sorry. All right. Yeah. Awesome. Awesome. Thank you. So I am going to be walking through what are called some Jupyter notebooks, and I'm going to use them a little bit like slides, but we're going to also run some code in them. So what is the Jupyter notebook? I'm not going to focus on that because it's not critically important, but what you're looking at on screen right now is a Jupyter notebook, which is a browser-based Python environment. And with that environment, you can blend code and markdown and plots, which is why they're really cool for teaching and for displaying your work. However, let me be very clear. It is not at all important that you know what the notebook is, that you use it today. When we write code, you can write it in any Python environment you like. So don't worry about the notebook, but just know that that is what you are seeing on screen. Now, that being said, the notebooks that I'm going to partially walk through, I will go ahead and put a link to them in chat. And that way, if you are interested in like opening up those notebooks and you know how to do it, here's a GitHub repository where you can do it. I've put that link in the chat there. Okay. So let's see. Okay, let me just go ahead and jump right in with the content. And so we're going to start off with just talking about, what is machine learning? And if you will, a brief agenda. What is it? What are the two categories of machine learning? What are some examples? And how does it work? How does it think? Okay. And the reason I want to talk about this, especially if you're the type that just wants to jump in and write some code, I totally understand that interest, but there's no point in writing the code for it if you don't understand kind of the foundational underpinnings of machine learning. So that's what we're going to hit here first before we write any code. Okay. So what is machine learning? All right. And this is a definition I stole from, semi-stole from Jan LeCun, who runs artificial intelligence, I think the artificial intelligence team at Facebook. He's quite well known in the field. So what is machine learning? It is the semi-automated extraction of knowledge from data. So there's a lot packed in that sentence, and I'll just highlight it right here if you wanted to kind of follow along. The semi-automated extraction of knowledge from data. So what does that mean? Well, first, you have to start with a question, okay? Machine learning is not a process you apply without a goal. You have to have some sort of goal, and that goal is in the form of a question, and you believe that the answer to your question is in data, okay? You have access to data, you believe it has the answer to a question. So that is the goal of machine learning. Now, I'm calling it the semi-automated extraction of knowledge from that data. So I'm going to answer my question in a semi-automated fashion. It's automated in the sense that a computer is providing that insight. And you will see that today. The computer is learning something on its own. However, I'm calling this semi-automated because it requires you to make smart decisions. So that is all to say that machine learning is not an automated process. It's not a fully automated process. It is a semi-automated process. There may be a time in the future when machine learning is just click a button and it just happens. But for now, it does require expertise and practice and experience to be good at it, okay? So that's kind of the basics of machine learning. And I'll give you some examples in a moment, and then I want to hear your examples or what you guys and girls think are examples, and we'll talk about them. But that at the high level is machine learning. Now, there are a number of different categories of machine learning, and the biggest one, at least in terms of popularity and utility, is called supervised learning. So that is one type of machine learning. And the way supervised learning works is you make predictions using data, okay? So one way you might summarize supervised learning is that you are learning from the past to predict the future. Okay. In all cases for machine learning, you're learning from the past, but in the specific case of supervised learning, you are learning from what's happened in the past to predict the future. Okay. So for an example, let's pretend you've got a spam filter, or rather your email software has a spam filter, and it's deciding whether every email you receive, is it spam or is it non-spam? and non-spam is another word. Is it spam or non-spam? And ham is another word for non-spam, which I think is brilliant and kind of funny. But so the emails that show up in your inbox are ham, and the things in your spam folder are spam. So that is an example of supervised learning. Okay, there is an outcome we are trying to predict. And in this case, the outcome is, what is the email? Is it spam or is it ham? Okay, there's an outcome we're trying to predict. And I'll talk in a minute about how it decides, but it's learned from past examples. So what's an example, and just throw this in the chat if you have an idea. What do you think is an example of a supervised learning problem that you can solve with data? Okay. Let's see if anyone's posted anything here yet. Alan mentioned a minute ago, my use case is the classification of test failures. Okay, so there's some sort of testing process. There are successes and failures. The thing you're trying to predict is, maybe he's got different types of failures and he's trying to decide which type it is. He's trying to predict which type of failure is occurring, or perhaps he's predicting failure or success. Either way, that's a great example of supervised learning. Rayed says face detection. So that, yeah, that's great. So face detection is kind of, you could frame it as supervised learning by saying, here's an image. Is there a face? Yes or no? So we've trained a model, which we'll get into in a minute, on past images of faces, and we show it a new image and we say, is there a face? You could also frame it as, where is the face? That's a little bit trickier to explain how that would work. Francisco mentioned regression. So regression is a type. Regression is a bit of a complicated word in that it refers both to a machine learning model and a type of supervised machine learning. So I'll get back to that. Ricardo said a diagnosis based on clinical features. Great. So you've got, let's say you're a doctor and you've got a patient that comes in and they have certain symptoms and you want to diagnose them. It might be funny to think of it to you as like a prediction, but because you're like, well, either you're right or you're wrong. You're not predicting, you're identifying. But in the language of supervised learning, that is prediction, because you believe there is some truth that you're trying to, quote, predict. So you can think of supervised machine learning as predicting or identifying, if predicting sounds strange, but that's great. I'll mention a few more that have been in here. Let's see, detecting objects in an image. Great. Predicting house prices using features of previous houses from Hakar. Great. So you want to predict, like Zillow. How do they decide their Zestimate, as I learned it's called? How do they decide that? Well, they're actually using machine learning to predict the value of a house based upon attributes of that house. And I'm getting a little ahead of myself, but the thing I'm trying to emphasize here is it is a supervised machine learning problem if you are trying to predict something, okay? Now, let me contrast that with unsupervised learning, which might make this more obvious if you're at all stuck on what is supervised learning. So unsupervised learning is when you're extracting structure from data, okay? So one example, a classic example, is called clustering. And you can think of it as, let's pretend a grocery store wants to understand the type of shoppers that come in to the store. There's not, you might think, oh, well, that's obviously supervised because you're trying to predict like what group they belong to. But that's not exactly it, okay? And here's why, okay? When we talk about a cluster of people, we may say, oh, well, there's the new parents that shop at our grocery store and they buy lots of diapers and baby food, maybe. And then there's the super healthy people that buy only organic and certain high quality goods without additives and whatever. So you're coming up with groups, okay? But here's the thing, and this is the key point about supervised versus unsupervised learning. In unsupervised learning, there is no right answer. So if I worked for that grocery store and they say, oh, how many clusters are you going to make for us when you examine our grocery store shoppers? I would say to them, I have no idea because there's no right answer. I can make 2 groups. I can make 1,000 groups. And then they might say to me, oh, well, that's strange. But, let's say you make 10 groups, like how many people are in each group and how often do you get it right? And I would say to them, there's no answer to that. There's no right answer in unsupervised learning. You are trying to understand your data, but there's no right or wrong answer, okay? There's no thing you are trying to predict that you can say, okay, I got it right, or I got it wrong, or, oh, this person belongs in this cluster, or this person belongs in that cluster, okay? So again, supervised learning, you are trying to predict something and you can say, yes, I got it right. No, I got it wrong. Whereas unsupervised learning, there's no right or wrong answer. You are just trying to extract structure from data, okay? You're trying to learn from it, okay? So those are the 2 types of machine learning. And we're going to focus today on supervised learning. And that's definitely my specialty. I'm not great at unsupervised learning. There's something about me that like I like to know when I'm right or wrong, or know whether I'm improving. And unsupervised learning is very it doesn't kind of help you like, am I getting it right or not? Francisco asks, is it just like data description? And it's not in the sense of like doing an exploratory analysis, for example. You will learn things and you can come up with descriptive statistics. With unsupervised learning, you are actually building a model, and we'll get to that in a minute, but you can't say my model was right or wrong, okay? So I hope that helps. It'll be easier to understand the answer to that a little further on. So hold on to that and let me know at the end if you're stuck on that concept of the difference between unsupervised learning and just data description. One person in the chat says, if you use an unsupervised approach and only 2 clusters, isn't that like a yes, no classifier? No, in that there's still no right answer, okay? So let's go back to this picture here. This point up here, is it in the, okay, so, and this is actually a question for the chat, okay? So let me know what you think. This point right here, is it in the red, the green, or the blue cluster? Yeah, so green. And you're like, okay, well, it's closest to the green, so obviously it's there. But what about this point right here in the middle? I know it's colored blue in this picture, but pretend all I told you was there are 3 clusters and you have to decide the color. What should the color of this point be? Should it be green, blue, or red? Trey says grew. I like that. Blue, green. Okay. We've got some greens. Okay. So that I'm trying to make my point that there's no right answer. So unsupervised learning does not have a right answer. It's a matter of judgment and expertise. Supervised learning, you have to have a right answer. Okay. Let's see. Ricardo asked, can we mix both approaches, supervised and unsupervised, in one model? There are other types of approaches called like active learning and semi-supervised learning and reinforcement learning that are kind of like a blend. But I wouldn't call it the same model. I would just call it a different type of machine learning. Okay, I'm going to pause on questions for there and talk about how machine learning works. If you've, at any time, as we were talking about before, if at any time you've got a question that I didn't answer, you can always scroll down below the video and ask it there so that we can get back to it later. But I want to talk about how machine learning works, okay? So these are the high-level steps specifically of supervised learning. Okay, I'm not going to be talking about how you do unsupervised learning. There are really just two steps. Number one, you train a machine learning model using labeled data. Okay, you train a machine learning model using labeled data. We will do this in a little bit, and you'll see how easy it is in terms of code. But let's talk about these terms, okay? What is labeled data? Labeled data is data that has been labeled with the outcome. It has been labeled with the truth, okay? This is supervised learning, and so there is a right and wrong answer, okay? So labeled data, in terms of our email example, our spam filter, labeled data is past emails where a human has said, this is spam or this is not spam, okay? So labeled data is data that has been labeled with the outcome. Now outcome, we'll talk about terminology in a bit, but outcome is like the target. So when we were talking about house prices, the outcome is the price. It's the thing you are trying to predict, okay? So in order for Zillow to say, oh, I predict this house is worth $200,000, they must have data of past houses with prices. And that price is the outcome, okay? Now, so we are going to train a machine learning model using that data. So the machine learning model, what does it do? It learns the relationship between the data attributes and the outcome. So let's talk about a different example than I've been using, okay? So let's pretend we are predicting how many retweets a tweet will get, okay? So I'm trying to predict how many retweets a tweet will get. I have some past data about tweets. I have some past tweets and how many retweets they got. What are some attributes of the data that you think could be used to predict the number of retweets? What are some attributes you think could be used? So go ahead and post your ideas in the chat. All right, so Alan says words used. Great, great. Sentiment, says Grant. And sentiment, if you don't know, is like how positive or negative a tweet is. The person who made the tweet, says Trey. And I would say maybe more like how many followers that person has or other attributes of them, their job. Hawker says time of day. We've got topic. We've got gender. We've got subject. All of those are great. And let me just mention now a piece of terminology. Those things we just said, time of day, words, followers, those are called features, okay? They are the attributes of the data. So what, and Sebastian added, if using a popular hashtag, great. So how many hashtags are they using? Are they using a popular hashtag? What are the keywords being used? All of those are called features or attributes of the data. What does the machine learning model do? It learns the relationship between the attributes of the data and its outcome. In other words, if I want to build a machine learning model that predicts the number of retweets a tweet will get, what I do is I gather past data about past actual tweets with the number of retweets, the number of followers that person had, the sentiment of the tweet, the time it was posted, the day of the week, their gender, all of those things. I'm gathering that data about the past tweets, and the machine learning model is going to use those things to predict for a new tweet, which gets us to step number 2. We train a model, and then we make predictions on new data for which the label is unknown, okay? So we learn from the past, that's step 1. We predict the future, that is step 2. And by future, I don't mean like a tweet that hasn't been written, but I mean a tweet you've written but you haven't posted. You know, like you don't yet know how many retweets it's going to get, but I can tell you how many followers that person has right before they hit the tweet button. Okay. So that is how machine learning works. If in supervised machine learning, if you benefit from kind of a picture, this might help. What you're looking at here is you've got what's known as training data. That's past data. You've got labels, which is the number of retweets in this example. And you're getting an algorithm. You've got an algorithm. You feed those into the algorithm, and it outputs a trained model that has learned the relationship between gender and number of retweets. It's learned the relationship between time of day and number of retweets. And then this is step 2. You pass in a new tweet to the trained model, and it outputs a prediction. Okay. So that's kind of the high level overview of how machine learning works. Now, when I talk about models, I'm talking about things like linear regression, logistic regression, decision trees, random forests, naive Bayes, ADA boost, gradient boosting machines. All of those things are machine learning models. Those are things that learn the relationship between features and an output. Okay. All right. So that's kind of the high level on machine learning. I will just say that you want to make sure you are building a model that predicts the future, because what you don't want to do is predict the past. Okay. So what you don't want to do, well, this is probably getting ahead of myself. So I'm going to pause on that point. Okay. So that's the high level on machine learning. Okay. I'm going to move to a different notebook and just talk briefly about Scikit-learn before we get into some code. Okay. So as I said, feel free to keep posting questions below the video and see if that helps. Okay. All right. So the second notebook I'm just going to pull up here. I'm just going to talk briefly about Scikit-learn. And what is Scikit-learn? Scikit-learn is a library or package, you can think of it as. It's a Python library for machine learning. Okay. You can do supervised learning. You can do unsupervised learning, both in Scikit-learn. Okay. So why briefly are we using Scikit-learn? Well, it provides a nice consistent interface to machine learning models. Okay. In other words, you're like, I want to try model A and model B. Well, you can switch between models very easily. We're going to talk about tuning parameters, which are things you tune to get your model to perform better. Okay. It's got great documentation. It helps you do things outside of just model building, like data preparation. And it's got a really cool active community. Okay. So lots of great things about Scikit-learn. That's all I'll say. I want to move into some code because I know a lot of you are here for that. I do want to mention, if you haven't installed Scikit-learn yet and you want to follow along today, or probably even easier, you want to follow along afterwards, I will just copy 2 links into the chat. One is how to install Scikit-learn on its own. And one is the Anaconda distribution of Python. The Anaconda distribution is a great way to get started with scientific packages in Python, including Scikit-learn. It also includes the Jupyter Notebook. So that's a great way to get started with doing scientific computing in Python, including machine learning. It's a giant download, so I wouldn't download it right now, but download that afterwards, and it'll be an easier way to get up and running with Scikit-learn. Okay. So now what I'm going to do is get into some code and an example data set. All right. All right. And Trey just mentioned in chat, this chat is recorded. And so if you're having trouble, whatever, there will be a recording you can go through. I know it's not as good as live, but that's just kind of the reality of modern day video streaming. Okay. So I've pulled up another notebook, and we're going to talk about a data set. And then we are going to load it into Scikit-learn. We are going to talk about some more machine learning terminology, like features that I've mentioned already. And and we're going to talk about how to work with data in Scikit-learn. And let me say right now, I know that this is not your data set, and you probably have a data set you want to apply machine learning to. And I promise that the most important thing you can do is to understand how Scikit-learn works with data, so that when the time comes to load your data into Scikit-learn, you do it properly. Okay. So I'm going to pull up a really simple example data set, and then we're going to use it to learn how do I work with data in Scikit-learn. Okay. Now, the data set we're going to use, it's called the iris data set. All right. And there's a reason I like this data set. Number one, it's simple. And number two, it's famous. And number three, it's built into Scikit-learn. Okay. So it's a famous data set from, I don't know, 50 to 100 years ago. And the way this data set works is that an iris is a flower, by the way, and someone, a scientist, I believe, essentially collected 50 samples of 3 different iris species, 150 samples total, okay? And that scientist measured the 4 attributes of each of those irises. Okay. Just like the features of that tweet, this scientist measured the attributes of these irises. Okay. So what did they measure? They measured sepal length, sepal width, petal length, and petal width. And it's not really important to understand those. Just know they are measurements of an iris. Okay. So I'm going to show you the data set without leaving the notebook. Don't worry about this code. Do not bother retyping this code in Python. Just trust me, it's not important. what I want you to see is just the structure of this data. Okay, this is critical. If you want to put your data into scikit-learn for machine learning, it has to follow a certain structure. And you can think of it like rows of a spreadsheet, okay? So every row represents one iris flower. So this is a flower, this is a flower, this is a flower, etc., all the way down to the end. There are 150 flowers, and so there are 150 rows, okay? And this last row is telling me that the sepal length of this flower was 5.9, the sepal width was 3, the petal length was 5.1, and the petal width was 1.8, and this was a virginica. That's the name of the species of this iris, okay? So this is the structure you're going to want to get your data in which every attribute is kind of like a column, okay? And then one of your columns is that outcome, what we're going to call our response or our target. It's the thing we're trying to predict. You make that one of your columns, okay? So to come back to what we did in the last notebook, these are the features. Our model is going to learn the relationship between these numbers and this species, and then we're going to use it to predict the species of new flowers, okay? All right, so I've probably repeated some stuff that we'll see on the screen below, but that's okay. We're going to load this data set into scikit-learn. And the reason I want to use a pre-built data set is because teaching you how to load your own data set, it takes more than we could cover during this, this webcast. So we're going to use a pre-built data set, and I'll talk at the end about how to load your own data set. But this code, if you are following along on your own computer and you're typing this into Python, this code right here is not, you do need to type it, but it's not important to understand because in the real world, you're not going to load example data sets. You are going to load your own data, okay? So basically, there's a, and when you see, you'll see, just so you know, you'll hear me click on the keyboard. That's when I'm running these notebook cells. It's just how I'm running the code in this environment. So what I've done is I've imported a function from the scikit-learn.datasets module. And let me just mention while we're here that you'll notice I did not say import sklearn, okay? And the convention is not to import the entirety of scikit-learn. The convention when coding with scikit-learn is to import individual modules, functions, etc., okay, or classes. So I'm just loading one function and then I'm going to use it. All right. So there's a special object type called a bunch that contains the iris data set and some of its attributes. So I'm just running the load iris function, saving it in an object called iris, and checking its type using the type function, okay? And this, it's just a special scikit-learn format, okay? Now, I'm just gonna, iris, this object, has various attributes, and one of them is called data. So I'm just gonna print, I'm running the print function on iris.data. And what you'll see is the data from this data set. The same stuff we saw above, 150 rows. And here are the 4 columns representing the 4 attributes, okay? Now, there's not a 5th column because that's stored separately. So don't worry about that 5th column for the moment. All right. So a bit more terminology, and then we will get into building our model. Okay. So each row is an observation, and each column is a feature, okay? So observations, samples, records, those are all rows in the data set, okay? This is an observation. Each column is a feature, sometimes called an attribute or a predictor. So one of these columns, that's a feature, okay? So I'm just gonna print the names of the 4 features, okay? And then I'm gonna print the iris.target attribute, because I wanna show you that scikit-learn is representing the class, it's representing the output as numbers, okay? As integers, okay? This 0 means one of the classes, one of the species. The 1 means a different species, and the 2 means the third species, okay? So these are just representations of the target classes, the response classes, okay? There are 3 species, thus there's 0, 1, and 2. And I know it's not entirely clear from this without having seen it before, but this allows me to know that the 0 represents setosa, the 1 represents versicolor, and the 2 represents virginica, okay? Now, I know that's a lot to take in. The code we've run so far, again, I want to emphasize, is not the most important part here. This is about conceptually, how do I structure my data set so that it fits into scikit-learn? All right, a bit more terminology, and then we will get into model building, okay? I've been talking about how that target is also called the response or the outcome. That is the thing we're trying to predict. So in this case, we're trying to predict which species of flower. And then there are 2 kinds, coming back to something someone mentioned before in the chat, there are 2 kinds of supervised learning problems. One is called classification and one is called regression. The only difference between the 2 is that in classification, the response is categorical. It is unordered categories. In regression, the response is ordered and continuous, meaning numeric. So let me give you 2 examples, okay? When predicting whether an email is ham or spam, that is called classification because there are categories, ham and spam, and they're not ordered. There's no ordering. When we're trying to predict the price of a house, that is called regression because the response is continuous. It is numeric, okay? So let me ask you, and I want to just hear in chat, see if you're getting this. When we are trying to predict the species of an iris, are we doing a classification or a regression? All right, great. I see some folks in chat. Everyone's saying classification. Great. There are 3 classes. There are 3 categories. They are not ordered. Setosa, versicolor, and virginica may be represented as 0, 1, and 2, but they are unordered. Okay. Now, okay, let's move on. I can give, if you have more questions about whether something is classification or regression, we can get to that afterwards. But I want to harp on this idea of how your data has to work in order to be used in scikit-learn. And there are basically 4 rules, okay? Number 1, the features and the response, the features being those attributes and the response being the species, those things must be separate objects. So I'm just printing to show you that the type of that iris.data and the iris.target, they are 2 separate objects, okay? You put the features in one object in Python, and you put the response in another object in Python, okay? Number two, they should all be numeric, okay? So the features have to be numeric. And here's why. And I haven't told you about how models work. Machine learning models do math, okay? Machine learning models do math or something very mathematical and logical, okay? And you can't do math on text, so you do math on numbers. So your features have to be numbers. So for instance, if we're going to predict how many retweets a tweet gets, we can't just put in the text of the tweet. We have to translate text into numbers, okay? Let me say that again. If you want to predict how many retweets a tweet will get, and your tweet, one of the features you want to use is the text, you have to translate your text into numbers because machine learning models do math and math requires numbers. Now, how do you do that, you might ask? Well, that is far beyond the scope of what I can do within this webcast. I do actually teach a course that covers a lot of that. So that's the second rule. And I saw your question, Nomi, and I will get to that in a minute. The third rule, okay? The features and the response should be NumPy arrays. And if you've never heard of NumPy, that's okay. NumPy arrays, NumPy is a package for scientific fast computation. And scikit-learn likes NumPy. Okay, so you have to put your data in a NumPy array. Now, it turns out that if you put your data in an object that looks like a NumPy array, such as a pandas data frame, scikit-learn will understand how to work with it. Okay, you can even put it in like a list of lists, and scikit-learn will understand. Okay, the fourth rule is that you have to have specific shapes, okay? And this is one of the trickiest things about starting with machine learning. But if you have understood the conceptual material up to here, I think you'll get it, okay? So don't worry about the code, but I am printing the shape of the iris.data and the iris.target, okay? This is telling me that my feature matrix is 150 rows by 4 columns, okay? So every observation should be in its own row. Every feature should be in its own column. And I know that sounds simple, but I promise you it's not always as simple as it sounds. But that's what you have to do. Every observation, 1 row, every feature, 1 column, okay? Now your response variable, the thing you are trying to predict, it should be a one-dimensional object in which its length is the same as the number of observations. Okay, so let me break that down for the iris data set. Our iris data set has 150 rows and 4 columns, okay? Because there are 150 flowers. The iris.target is our response, and there are 150 of them. Why? Because our machine learning model is learning the relationship between 150 observations and 150 classes. Sorry, 150 response values. So what I mean is you can't say to a model, let's go back to the Twitter example. If I collect data on 100 tweets, I have to also collect data on, for all 100 of them, how many retweets were there? Because my model, if I say hey model, I want you to learn the relationship between the features and the number of retweets, every observation has to have a corresponding number of retweets. Because if I don't have that number, the model can't learn the relationship between the features and the response. Okay, so that is key. Okay, my features are 150 by 4. It's a 2-dimensional object. My response is 150 period. Okay, it's a single dimensional object. Okay, let me do one last thing and then I'll answer Nomi's question and then we will finally build our model. We are going to store our feature matrix in an object called capital X, and it's capital by convention because it's 2-dimensional. And I'm storing my response vector in Y, okay? And it's a lowercase y, and that's the convention because it's a single dimension, okay? All right, Nomi asked, are there separate machine learning algorithms for classification and regression? The answer is yes. Yes, the short answer is yes. What are some examples? So decision trees can actually be used for either. K-nearest neighbors can actually be used for either. Linear regression is a regression model. Logistic regression is a classification model. Neural networks can be used for either, and so on. All right, Trey asks, am I getting the terminology right? 150 observations equals 150 flowers. That is exactly correct. 150 responses equals 150 classifications of those flowers into one of the categories. Yes, correct. And each flower has 4 features that are used for figuring out the category. All correct. Okay, so if you just heard what I just said and you're like, wait, what was that? Go into the chat and look at what Trey just typed because that was a nice summary of what we've just been talking about, okay? So the observation is the flower, the response is its species, and the features are those 4 attributes of the data, all right? Minaj, how to choose an algorithm. I will talk about that in a little bit. Nomi, is a feature and a predictor the same thing? Yes, those two are the same thing. Okay, so I am going to open up one more notebook and we are going to finally build a model, okay? Now, you've noticed that we are an hour into the webcast and I hope you are still sticking around and finding this interesting. Because we're about to build our model. I will let you know that Crowdcast has a hard cutoff at 90 minutes. So I'm going to get through this hopefully in about 10 minutes and make sure that we leave about 20 minutes for questions. Okay, so that's my goal here. All right. Now, I am not going to talk about how to choose a model right now. I will talk about it generally, nor am I going to explain the model we're about to use because that would take quite a bit of time. What I want to get into is showing you how easy it is to build a model once your data meets those 4 requirements, okay? All right. So just as a recap, our data set has 150 observations. It has 4 features. The response value is the species, and this is a classification problem, not a regression problem, because the response is categorical, okay? So that's a quick summary of our data set. Now, I'm gonna skip past this part where I explain k-nearest neighbors. And I will tell you how you can get this explanation after today's webcast. But these 4 lines of code, if up to now you have not been following along and we're just waiting to build a model, Okay. These are the 4 lines of code you need to run right now in order to catch up with where we are. Okay. So you haven't missed anything if you haven't been typing any code up till now. Just run these 4 lines of code and we will have defined our X, our feature matrix, and our Y, our target vector. Okay. And again, I'm going to print out their shapes. Okay. So the X, our feature matrix, is 150 by 4. And the Y is 150 period. Okay. So every row has a species associated with it. Okay. So here is the scikit-learn 4-step modeling pattern. And I think you'll be surprised, given the complexity of machine learning, you'll be surprised how straightforward this is. Okay. So step 1, import the class you plan to use. All right. Now, scikit-learn is well organized. Let me say there are dozens, perhaps even hundreds of machine learning models. Okay. I am importing one of them. I'm not going to talk right now about how I chose it. Just know I chose a particular model and I'm going to import it. So I'm going to say from sklearn.neighbors, import kneighbors classifier. Now, what is sklearn.neighbors? Well, basically, scikit-learn is well organized into little modules that contain related models. Okay. So I'm importing a model that thinks in terms of neighbors. Now, don't worry about what that means. I'm just saying I import it so I can use it. This is me importing a model so that I can use it. The next step, step 2, is to instantiate the estimator. Now, what does that mean? An estimator is a model. That is scikit-learn's term for model. Okay. And instantiation, that's just an object-oriented programming term. It means make an instance of. And let me show you what I'm doing, and then I'll explain what the point was. I'm going to say KNN equals kneighbors classifier parentheses n neighbors equals 1. Now, what am I doing? I'm creating a model called KNN. Sorry, I'm creating a Python object called KNN, and that object knows how to do kneighbors classification. In other words, kneighbors classifier is a type of machine learning model. That model thinks in a certain way in terms of the relationships it can learn between the features and the response. Okay. So KNN is an object that knows how to do KNN classification. And then n neighbors equals 1 is a tuning parameter for the model. Okay. These are also called hyperparameters. Now, you might be asking, what's the role of the hyperparameter or the tuning parameter? Well, if I said to you, hey, we're going to use past tweets to predict number of retweets, and I said, I want you to use a decision tree model, okay? That's not enough information for you to build the model. You actually need to make decisions about the parameters of that decision tree. Now, each model, each type of model has its own parameters that you have to tune. Those tuning parameters determine they tweak the performance of the model. Now, there are a lot of default parameters. You can just use those, but you're not going to get best model performance. So for instance, if we're predicting ham or spam for an email, I might get 80% accuracy with kneighbors classifier n neighbors equals 1. And I might get 82% accuracy with k-neighbors classifier and neighbors equals 5. Okay, so I can tune the parameters of the model for optimal performance. Okay, now how you tune a model is beyond the scope of this webcast. I have other videos about that, and I will talk about that. But for the moment, you'll just have to kind of treat it as a black box. Okay. All right. All the default parameters of a model that you don't set during instantiation, which is this, are set to the defaults. So here are the other parameters of k-neighbors classifier: algorithm, leaf size, metric, p, n jobs, metric params, weights. All of those are parameters that could be tuned. I didn't set those parameters during the instantiation, so they're set to their defaults. Okay, so step 1, import. Step 2, instantiate the estimator. Okay. Step 3, fit the model with data. This is coming back to what we talked about at the beginning. You want a model to learn the relationship between your features and your response. That is called model training. That is also known as model fitting. Okay. So I am learning the relationship between X and Y. Okay. I'm learning the relationship between X and Y, because what is X? X is our features. What is Y? Y is our response vector. So right now, when I say knn.fit X comma Y, I'm saying knn object, I want you to learn the relationship between X and Y. Okay. And finally, step 4, predict the response for a new observation. Okay. This is where KNN is our trained model. And let me show you what I mean. Okay. When I said so coming back to this diagram, I think this will be helpful if you got lost anywhere. This part is X. Okay. This is our training data. Y, these are our labels for the training data. Okay. Here's X. Here's Y. This is KNN, our model we're using. Once I've done knn.fit, it's a trained model that is ready to accept new out-of-sample data. Okay. Now, the code for that is knn.predict 3542. And what am I passing it? Well, I'm passing it a list of lists. Don't worry exactly why. It would take a little while to explain. But the point is, KNN is a trained model, and I am saying to KNN, my out-of-sample observation, my new flower. Let me actually step back and explain this in plain language, okay? KNN has learned the relationship between the measurements of irises and their species. I am walking up to KNN with a new flower, and I'm saying, hey, KNN, my flower has a sepal length of 3, a sepal width of 5, a petal length of 4, and a petal width of 2. What do you think the species is? And that is what is happening when I say knn.predict. Okay? knn.predict is saying, I want you to predict what species this is. Okay? And it predicts a 2. Now, 2 means Virginica, which we know because we coded them as Setosa equals 0, versicolor equals 1, and Virginica equals 2. And importantly, KNN has no idea what these numbers represent. It doesn't know what 3, 5, 4, and 2 represent. It doesn't know what the predicted value of 2 represents. Okay. It does not understand those things. Okay. It is just doing math. Now, I will do one more thing. I will just show you that you can predict for a new, you can predict for multiple observations at once. And in this case, and that's usually what you're going to do. So now I'm passing the predict method to different new irises. And it's saying, oh, this first one, I think is Virginica. And I think this one is Versicolor. Okay. I'm not going to show you these last 2 parts. I will just say what's in them, and then we will get into some Q&A. Number 1, this is just a little code snippet to show you how to use a different value for your tuning parameter. And this little section shows you how to use an entirely different classification model for the same task. Okay. So this is showing you, if you were following, you might have noticed that the model building process took a total of 4 lines. And using a different model took a different lines. That is how simple the actual model building process is in Scikit-learn. Okay. I think for the moment, that is all I'm going to show on the screen. So maybe Trey, let's go ahead and just put our faces back up, and then I will start answering some questions, both from the chat and from below the video. And let's see. So Trey asked, well, I'll just repeat what you just asked, Trey. Right. Do I have this right? KNN. Oh, KNN is K nearest neighbors, which is one type of machine learning algorithm that can be used for machine learning. That is exactly right. KNN is a model, okay? It thinks about machine learning in a certain way. A different model like linear regression thinks about it in a different way. Decision trees thinks in a different way. Random forests thinks in a different way. So there's obviously a lot to choosing between models. And actually that leads into some of the questions from below. So let me say right now it is, at least on the East Coast of the US, it's 2:15. So we've got only about 15 minutes left. I'm going to pick out some specific questions and I will answer the rest or some of the rest afterwards, and you can come back to this page and look at them. But in about 10 minutes, Trey and I will wrap up, and I'll just share some resources. He can share some more information about Python Weekly, the weekly Python chat. But I'll just jump into questions now, and then we'll wrap up in about 10 minutes. Okay. So how to choose an algorithm in machine learning? That is a great question. So it's not easy is the short answer. And as I was trying to explain, different machine learning models think differently. Okay. Each model has its own strengths and weaknesses. So for example, let me just give you an example to make this concrete. K nearest neighbors is a good model when you have a lot of observations and not many features. Okay. How do I know that? Well, I understand how K nearest neighbors works and I studied it. Okay. So the real answer is, if you want to know which model to use, you learn how a lot of models work, and then you'll have a sense for which model is better than others. Not only do you have to choose which model, but you have to choose how to tune that model. So there's really a lot. To choose, called comparison of machine learning models, and I'll just paste it into the chat, and you can check it out, and it talks about the advantages and disadvantages of different models. Okay, yeah, so feel free to check that out if you are interested. One question from the chat: does Scikit-learn support ensemble models? Yes, it does. Okay, let me go back to the questions underneath the video. Time series analysis using machine learning. So what is that, and how do you do it? Okay, so time series data is data in time order. So the best example of that is stock market data. Is like, you know, every second or every minute they record the price, and that is time series data. Time series analysis is an exploratory process for understanding that data. What I think you're actually referring to is time series forecasting, which is prediction of the future. That's like predicting the future of a stock price. That would be called time series forecasting. How do you do that with machine learning? Well, you can do it, but the tricky part is you have to build your own features in a smart way. So I can't, like an iris, I just measure its flowers, and maybe I have some domain expertise that says, oh, the height of the iris is related to its species, so I'll measure the height. I'll measure its, where is it located, or something. With time series data, you have to create those features in a different way. So yes, you can do that with machine learning. It's tricky, which is why there are some specialized techniques that have been used for time series forecasting that are not like, they don't think in the same way that of what I've just explained. Okay. The next question is about neural networks. And I'll just say briefly, let me say, like a simple model like k-nearest neighbors, when I teach it in the classroom, I spend at least like an hour on it. When I teach decision trees, like a really good lesson on decision trees, which most people think is like a simple model, I spend about 4 hours, okay? Neural networks, way more complicated, so I'm definitely not going to explain it right now. I'm also not qualified enough to explain it in a meaningful depth, but let me just say this about neural networks. You can think of it as a model, just like any other machine learning model. If you've heard of deep learning, so deep learning is like the really hot thing in machine learning these days, and for good reason. Deep learning is a set of techniques for training artificial neural networks. And the theory behind neural networks is they work kind of like the brain, okay? All I can say about neural networks briefly is it's a really deep topic. There are different architectures. There are skills, specialized skills you have to learn to know how to train a neural network. But I wouldn't start with neural networks before first understanding the basics of machine learning, okay? I don't think there's anyone who works with neural networks that if I said, oh, I need you to train like a KNN model, they'll know how to do it. They may not do it often, but they understand how to do it, because you have to understand the basics of model training before you can move on to neural networks, okay? All right, couple other questions I'll get to. Let's see.
You mind if I scroll down to the bottom and ask a couple that were asked later? So
sure.
You were using Python 2.
All right, yeah, let me
you were using Python 2. Are there libraries that make it so that you can't use Python 3, or was that just your choice?
No good reason is the short answer. So feel free to use Python 2 or 3, and you'll be good for most data science tasks, including machine learning with scikit-learn. Okay. Let's see. Modeling. Oh, I actually like your question, Trey. It sounds like choosing your features is really important, especially for predicting really fuzzy things. Can you use an algorithm to figure out which features are most important for your data and which ones are irrelevant? Feature selection is what it's known, is a really tricky topic. There are models that once you train the model, it can tell you which features were important. But most models, the way you do it is by trying different sets of features and seeing which performs better. And that's a way of backing into understanding which are important. So there are ways, but they're tricky, and there's not like one way, and it's not a solved problem. Let's see. What else do I want to answer? What is the process? So this is in the middle. It's from Grant. He says, what is the process that you go through to tune a model? Okay, so tuning a model means selecting a model. It means changing tuning parameters, and measuring and evaluating the model. Okay, so really, like, there's model evaluation is a huge topic. Now, the real question is, how do I choose the right model and know it's the right model for predicting the future? And this is where you get into a critically important topic called model evaluation. This is where you figure out whether your model, how good your model is at predicting the future, not predicting the past, okay? Because training data that you use to train a model it learns from the past, okay? I want to get good at predicting the future. How do I use the past to decide whether I will be good at predicting the future? That is called model evaluation. And the way you tune a model is by building a model evaluation procedure and a model evaluation metric. And then you try different combinations of things and see which performs the best. And if you've got a useful metric and a proper procedure, then that's a good way to tell how to best tune a model. Okay, it is. Oh, please.
Just for clarification, is a model the same as the algorithm, or is it the algorithm in combination with the features that you show?
I use the term algorithm and model interchangeably. Technically, there might be a distinction, but basically they're interchangeable. So a machine learning algorithm and a machine learning model are the same thing.
Cool.
To me. That's what I would say. Well, we are at 2:25, and I don't want to miss kind of the wrap up, and I can certainly answer some more questions in chat afterwards, and I'll add some comments on these questions. But maybe I'll just wrap up on a few things. I want to show you a couple resources. Number one is, if you didn't already know, the content I pulled from today is part of the content from my first 4 videos on my video series called Machine Learning with Scikit-learn. It's 4 hours long, plus I added a 3-hour live tutorial I did that builds upon it. So 7 hours of content if you really want to get into this stuff. And I will add a link right now in case you're interested. Definitely check that out if you want to understand machine learning with Scikit-learn, or get a recap of a lot of these things, understand k-nearest neighbors, understand model evaluation, okay? So that's one resource. Another resource I want to share is I have a video series about pandas, and pandas is a library for data exploration and for analysis and visualization, and it is the library to use to prepare your data set for machine learning, okay? So when I said it takes work to get your data set ready for Scikit-learn, you should use pandas to do that work. It so happens I have a free video series, 30 videos I'm releasing video number 30 on Tuesday of using pandas. I would highly encourage you to check those out if you want to understand how to use pandas. Final quick plug before, and then Trey, of course, I want you to, any wrap up you have. Final quick plug is I teach online courses. I'm releasing new material all the time. I'm going to have a course launching in a couple weeks. I'm going to have another course probably launching in November. If you want to hear about them, I would really love it if you went to and clicked the green button below the video that says subscribe to the Data School newsletter. Okay, click that button, fill out your name and your email. I will be getting in touch with you with lots of free resources as well as my online courses that I do sell. Okay, so let me just say thank you so much for your time. This was really fun and I really enjoyed it. Trey, what let you wrap up and then we'll keep answering questions till the clock runs out, I guess.
So my wrap up is going to be pretty brief here. First, thanks a whole bunch, Kevin, for coming on here. This was awesome. This is the first chat that we've done that was a little bit less of a chat between you and me. Much less of a chat between you and me, and much more of a learning experience from you with the audience here. This was a lot of great questions people asked here. Thanks everyone for asking those questions, and a lot of great stuff that you really broke down. I actually knew pretty much nothing about machine learning outside of a very, very rudimentary understanding that it was machines being trained to solve problems. Machines, I guess, meaning algorithms. And so this was a great breakdown. Thanks a lot for the announcements in case we do run out of time. We've got about 3 minutes left. I think we started a few minutes late. I actually don't see a warning that says it'll cut us off at 90 minutes. I think we should assume that, even though it's not there like it usually is. But I wanted to say next week's chat, I usually announce next week's chat at the end of Weekly Python Chat. I don't have it scheduled yet, but I'm pretty sure I'm going to do one on generators. And specifically, there's a topic that I haven't seen people really talk about much, turning while loops into for loops using generators. So making a generator in order to take one type of loop and turn it into another type of loop. I want to do a chat on that next week. And that'll just be me learning along with the audience. So if anyone's interested in that next week, you can join me then probably about the same time, same day next week. Questions real quick. There's a couple that I wanted to specifically ask because I'm in this same camp. Great. If you are okay at Python, but totally new to machine learning, this is from Alan Jones. What type of problems make for good learning options? So you know Python, you're totally new to machine learning. That is exactly where I'm at. Yes. What problem should I be trying to solve?
Yeah. So where you'll want to start is with data sets that are already ready for machine learning. So the data set we use today is from something called, and I'll just type it and someone can add a link. It is called the UCI Machine Learning Repository. Okay. So that website has hundreds of data sets that have been prepared for machine learning, and they already, people know that you can use the data to predict the response. So let me step back and comment on something. When we say we want to predict the number of retweets a tweet will get, and here are some features we should put into the model to predict it, right, those are just theories. My theory could be incorrect. Maybe the number of followers I have has no relationship with the number of retweets. So ultimately, I'm just guessing that one of those features, or more than one of those features, hopefully, has what's known as signal, not noise. In other words, it actually has predictive value. And the nice thing about the UCI machine learning repository, other than the fact that the data sets are already prepared, is that someone's already defined the response value, defined the features, cleaned them up, and actually has figured out that there is signal in those features. So that's where I would start, because you can actually practice the machine learning part. Because if you try to start with your own data set and data preparation, you're going to run into a lot of roadblocks that will discourage you, in my opinion.
If in that archive there is someone who's used an algorithm having to do with Twitter, they've already vetted that it seems to work on the stuff that they've used it for. So it probably maybe works for your prediction as well, if you're trying to predict the same type of thing.
So it's more, just to clarify, the machine learning repository actually contains, so what it contains is data sets, descriptions of those data sets, and links to papers where people have talked about applying certain techniques to those data sets. You can use those papers to get ideas for which machine learning models to use. However, when downloading the data set, it will not tell you, you must use KNN. And for what it's worth, it's good practice to kind of choose your own models and practice tweaking them and seeing the results. So the machine learning repository, its biggest value is that it's clean, ready to download data sets.
And just so we know, I got a warning from Crowdcast that the maximum recording time is now 2 hours.
Yep.
So we've got a little bit of time to answer the rest of these questions, if you have some time right now.
All right. Sure, I will. I told my wife I'd be done after 90
just
minutes,
a few
but
minutes.
I am happy to stay on and answer some questions. So, yeah. No problem. No, let's grab some good ones here. All right, and I'll just start at the top. If you have a question that you put in the chat and I haven't answered, you should add it into this list below here so I see it. But I'll just start at the top. Question, after the live chat, is someone interested in continuing with machine learning? Can you get for them projects to work on? How to practice? That, we've kind of answered that, but I would encourage you to go through my video series, both on Scikit-learn and Pandas. And I really like Kaggle as another source of practice. Kaggle is essentially a platform for competitive machine learning. And there are some machine learning 101 competitions, meaning specifically for beginners. And those are really fun because you can learn the machine learning workflow on data sets that other people are also working on, and you can compete against them to try to get the highest score, and you can learn from them in the forums and ask questions. Cool. So that's one thing I would suggest. Theory and practical skills. What are ingredients for getting hands-on machine learning using Python? Theory and practical skills. Boy, there are a lot. Practical skills for getting good at this stuff is like, how do I load data into Python? How do I prepare my data? Do I need to do anything to it? I need to explore my data to learn what might be good features. I need to create new features known as feature engineering. I may need to pre-process the data. I want to build a model, tune a model. All of those things are practical skills. The theory skills are like, the theory you have to learn is things like how to choose between models. How does each model work? What are the useful tuning parameters for a model? In what scenarios is a model particularly good? How do I properly evaluate a model, which is not always straightforward? How do I regularize a model? That's another kind of hot topic. How do I understand why tuning is working versus not working? So there are a lot of theory and practical skills to learn. I can't give you one answer for like, here's the one source for all of those. I can just tell you there are a lot of both. And I tried to cover a good bit of both in my video series.
Mind if I ask one from the bottom?
But yeah.
So Mike asks, what's the view?
Oh, sorry,
what's
please.
your view on the advantages and disadvantages of Python versus R, especially in visualization?
Great. I like that one. So I wrote a blog post. Let's see, and where did that go? Here it is. Okay. I wrote a blog post that was very popular once called, where is it? And I'll just paste a link. Should you teach Python or R for data science? I will paste it actually as a comment to the that question. I'll also paste it in the chat. The short answer is that both are good. I actually like machine learning in Python more than I like it in R. I used to like R more as a language. Now I like Python more as a language. They have their strengths and weaknesses. Visualizations, I really do like R for visualizations. But I'm really excited that there's a famous package called ggplot in R that I like, and finally there was an open source project porting that to Python, and that has made some significant strides lately. So that makes me really excited. But right now I do my visualizations in Python using either pandas or Seaborn, and both of those sit on top of matplotlib. So matplotlib is what most people use. It's a little more clunky than ggplot. Absolutely. It's kind of like base plotting in R, like the standard plotting in R. But that's kind of what I'd say. There's a lot to this topic. I'm happy to answer more questions about that. But let's see. And you feel free, if you see a really good one, grab it, Trey, but I'll just keep going from the top. Proper setup of training data. Okay. So in this case, and when you're pulling data sets from the machine learning repository, the UCI machine learning repository, it'll just give you a nice clean data set. But as I said, there's more you need to do to it. Let me give you some examples. You want to remove features that are irrelevant, okay? So if we're predicting what the number of retweets for a tweet, and one of the features was like color of the person's background that wrote it, you'd be like, that is irrelevant. And how do you prepare your data? Remove that feature. So that's number one. Number two, you have to remove missing values. So pretend one of your features is how many followers the person had at the time they tweeted. If you don't have that feature for all tweets, you either have to remove those tweets. Those are called missing values. You either have to remove those tweets, or you have to input what you might think of as fake values. Because remember, machine learning models do math, and you can't do math on missing values, okay? There are other things. Certain machine learning models require you to standardize your data. And by standardize, I mean center and scale your data, which means give it a mean of 0 and a standard deviation of 1. That's one type of preparation. Another preparation is categorical features. So let's pretend one of your features was was categorical, like what's a good unordered categorical feature for Twitter prediction? It would be like the person's job category. Let's pretend we had 10 job categories, and your theory was that people whose job category is data science are more likely to be retweeted. Okay, let's pretend. Job category data science cannot be put in a model, and you can't just do math on the words or the category data science. You either have to extract the words and turn those into numbers, which again is a deeper topic I can't really get into, but I do teach in an online course. The other way to do it is treat it as a categorical feature, and you do what's called dummy variables, or someone asked about one-hot encoding, same thing. You essentially translate a single feature with 10 possible values into 9 separate feature columns. Okay, so that's just, there are so many ways in which you need to prepare your data for machine learning that is I think what you're asking when you said proper setup of training data. The other answer I would give is just a recap on what we talked about during the chat, which is that you have to have the same number of observations as you do values in your response vector, right? So I think that's all I have to say about that. Let's see. Diane asks, what type of problems is machine learning good for solving? Well, supervised learning is good for solving problems in which there is a real answer. Okay. If there's no true answer, then that's not a good candidate for supervised learning. And I wish I had a good example offhand, but in general, you don't want to use machine learning if you don't have enough data, meaning like you want to predict something where your theory is that, okay, there's so many, I've got so many thoughts in my head right now. Sorry, it's hard to get them all together. If you have a theory that something is answerable using data, but you don't have the data, then that's not a good candidate. You should choose a problem where you believe there is data and you can get access to it, okay? Another example when it's not good is when it's arguably not good is when it's an extremely rare event, or an event that's never happened. So if you said, I want to predict when a earthquake will hit my house, well, like, how much data do you have on that? Or has it ever happened? Or maybe it happened once. You don't have a lot of instances to learn from. So you want to choose problems ideally where you've got a lot of data about where it's happened and where it hasn't. You've got a lot of training data, essentially. That's not the best answer. I'm sorry, but it's a tricky question. The question about what is backpropagation in neural networks? NN, he means neural networks. He or she, I believe. So neural networks, as I said, is a very deep topic. My disappointing answer is I can't summarize that in a meaningful amount of time, nor am I really qualified to. I try to teach things that I'm really good at teaching and I really understand well, and neural networks is not at the present time one of my specialties. So that's the best I can do there. Trey asks, a great question, Trey. Can machine learning help me analyze my social relations? What kind of cool things could I use machine learning to find out about my social network? Okay, so supervised machine learning would be good for making predictions. Like, you might want to predict, if I were you, I mean, this is maybe not a top priority, but you might want to predict how many people will show up at a webcast. Okay. And you would just have to think through, what data do you have about past webcasts and you'd have to incorporate things like the time element. That's very tricky because you want to separate out, let me say that, and this is a good teaching point. When I give a machine learning model 150 irises, it doesn't think of them in time order. It will output the same model regardless of whether you change up the order of the rows in the data set. Now, if your observations, meaning your rows of data, if your observations are time-based, there's a time element, like over time you have grown, you have to find a way to encode that as a feature such that your model can learn that time was like how far in the past it occurred, is relevant. So that's a really tricky. It's a really tricky topic. So that's how you would use supervised learning. How would you use unsupervised learning? You might cluster your followers into groups. Okay. There's something called graph. I can't think of the graph modeling. That's not the right term. I'm trying to think of the general term, which is basically creating graphs of their connections, and you learn like who are the influencers, that kind of thing. I don't work on that at all, so I can't really speak to it knowledgeably how you do it. You wouldn't do it in scikit-learn. You would use different software. I'm sure you can do it in Python. I'm positive. I just don't know the packages. So, all right. I'll just keep going. I mean, we're at, well, might as well just keep going, run out the clock. PCA and one-hot encoding, asks Andy. And one-hot encoding is another term for creating dummy variables. And you can do it in scikit-learn using the one-hot encoder. That's the thing where I said one-hot encoding is the thing, or dummy encoding is where I said you have a categorical feature you want to include in your model. There are 10 possible values. Thus, you create 9 features. And I actually have a video about that in my Pandas series you should check out. Again, if you come back to this page after the webcast, I'm going to have added comments, probably not today, but maybe tomorrow. I'll have added comments on links to relevant things, such that you can come back here and check out the links. PCA stands for Principal Components Analysis, and it's actually a type of unsupervised learning. And the way PCA works is, let's pretend you have 100 features. It turns out that in general, models perform better if they have less features, or rather if you eliminate uninformative features, as you might imagine. PCA is a way of, instead of selecting 10 of those features, PCA actually creates 10 features, or any number of features you want, that capture the variance in those 100 features. Okay. And that's like, if you've never heard that before, I expect like that will make no sense. It's a method for what's called dimensionality reduction, which is basically a way of reducing the dimensions of a data set so that a machine learning model has a better chance of learning from it. Okay. And I'll put some links on that. What is the difference between statistical modeling and machine learning modeling? Okay, lots of people debate about like what is modeling, and there's something called statistical learning, which is very similar to machine learning. Statistical modeling is not necessarily concerned with prediction. It is concerned with understanding, and sometimes you use understanding to get at prediction. Okay, so here's one way I would distinguish it. Machine learning is good at prediction, and via prediction, you can get understanding. Statistical modeling is good at understanding, and by understanding, you may be able to do prediction. So they fundamentally come at the problem in a different way, but you may be able to use them for similar
Could I
reasons.
add on to this one? Hidden
That's my best
Markov
summary
models.
on
Is
that.
that statistical
Yeah,
modeling? Is that machine learning, or is that something else?
So I don't know much about them, but I believe you would call that a machine learning unsupervised technique. And unsupervised is kind of at the boundary between. Unsupervised learning may sound a lot like statistical modeling because unsupervised learning is about understanding. You can't do prediction. So there are very fuzzy boundaries about what counts as unsupervised learning. It's a great question, but there's not like there's not like one true answer to that as far as I'm concerned. And even if there was, I'm not the best person. I am a supervised learning person. So that's where I'm best. Let's see. The question at the top, predictive modeling, supervised learning, unsupervised learning. I'm not sure what the question is. So feel free, that person, if you want to clarify in chat or comment, you can.
Yeah.
I'm just not sure what the
were
actual
added
question
before
is.
The chat started.
So we'll just move
so
on.
At this point, some of these will no longer be as relevant because you did cover a lot of these.
Got it. Cool. All right, I've narrowed it down to 8 questions left. See if we can get through. Is there a way to tell that a given model is optimum? There is no other way to increase the AUC and or TPR. Okay. All right. Here's my rephrasing of that question. Let's pretend I'm evaluating a model to figure out which model to choose, and I've figured out that I can predict the whether a flower is an iris. I can predict it 95% accuracy. The question is there a way to know whether I could predict it with 96% accuracy? Like, is it possible? Because there is an upper limit. The universe is not predictable. The answer is no. The upper limit is unknowable. Okay? So the usual way of dealing with this is you just accept the uncertainty and you just do your best, and you decide when you've spent enough time on this or you've run out of time, and your model is as good as it gets. AUC, by the way, is what's known as an evaluation metric. So it's one way to evaluate a classification model. I actually have a video on AUC, so I'll link to that later. Okay, I have Anaconda installed under Windows 10. How do I access scikit-learn? So Anaconda is a distribution of Python. To access scikit-learn, which is a library, you just open Python and, like from sklearn.datasets import load iris or something. Now, your question might be, once you've downloaded Anaconda, how do you even open Python? And there's actually different answers. You can use the Python shell. That's available. Just type Python at the shell. You can use the IPython interpreter. You can use the Jupyter Notebook, or you can use the Spider IDE. All of those come with Anaconda. What I was using is the Jupyter Notebook, but you can use any of those, and I'll add comments later on, like specifics of how to access each of those. But it's up to you. Real-time example of machine learning. I like this. So what's a real-time example? Voice recognition. Okay. So when you talk into your phone and you ask Google or Siri or whatever and say, like, give me directions to something, it recognizing your voice is a machine learning problem that it's doing in real time, essentially real time. The Facebook newsfeed. When you open Facebook, it has to decide what to show you at the top. Okay. And it's actually quite good at like showing you things that you're like, oh, I want to keep scrolling down. That is a real-time machine learning problem. Now, let me say that just because something is done in real time does not mean that the computation occurred in real time. Okay. If I'm Facebook, I would have a database of like, I don't know if I would do it this way, but when you open, this is a better example. When you open Netflix and Netflix shows you like, hey, I predict 4.5 stars for this for you, okay? Netflix, when the moment you hit its website, it did not run a machine learning model at that moment, okay? I can promise you that they did their calculations yesterday or the day before or a week before, so that when you came to the site, it's just accessing pre-computed predictions. That is machine learning that appears to be real time, but is likely not. I don't actually know for sure. So real-time machine learning means like you're interacting with it in real time, but there's no way to necessarily tell how much of it is happening in real time versus just being displayed to you in real time. Okay. The next question, what are these algorithms? Is there any mathematics used? How to choose the model? I've kind of talked about that already. There is mathematics behind every model. The mathematics depends upon the model. You can use any regression model for any regression problem. That is true. You can use any classification model for any classification problem. And choosing between them requires expertise. Yeah. Okay. If I am unable to make the time, will a video be available later? Yes, it will be available on this page shortly after ending. Apart from the KS statistic, what are the different ways of determining the cutoff point of a probability score in logistic regression? I think you mean like the threshold. I don't know what the KS statistic is, so I'm going to have to pass on that question. Oh, no, that was just my mouse. Okay, topic modeling. Topic modeling is about figuring out the topics present in a set of text and just, I mean, that's really what it is. I don't use it. It's a good way to understand what topics are present in a data set. But like, where do you go from there? It's kind of like unsupervised learning. I don't know if it's categorized as unsupervised learning, but it has the same objective. All right, 2 left. Wow. Okay. Can a model be biased? What is overfitting? Okay. Overfitting is about, how to explain overfitting. I will have a good link for this, but overfitting is learning the noise in the data rather than the signal. Overfitting is training your model such that it's good at predicting the past, but not good at predicting the future. Okay. So I don't want a model that is perfect at predicting the past. I want a model that's good at predicting the future. Okay. So that's what overfitting means, is when you're good at predicting the past, not the future. And the bias variance trade-off is what people are usually talking about when they talk about overfitting. A model can be tuned to be high bias or high variance, and the amount of error in a model is the sum of bias and variance. So essentially, you're trying to find a sweet spot between bias and variance.
So when people predict,
I'll link to a good
stock
article
market data and it predicts the past very well, but not the future, is that overfitting, or is that? Okay.
Yes. Cool. That is overfitting. Yes, that is overfitting. Now, there are lots of different ways you can overfit. There's not like only one path to overfitting, but that is what overfitting is. Yeah. All right, final question. Hi, Kevin. I have built my model to make a prediction. How do I put it in production in Python or a work environment for other people to use, like Shiny in R? Great question. So I'm gonna put. This is not my area of expertise again, but people have definitely put scikit-learn models in production using Flask, and then hosted it online using Python Anywhere. Now, I agree that having something like Shiny in R would be super useful for the Python community, and RStudio is really killing it in terms of trying to get data science people to use their products. Like, they are doing so many great things like Shiny, I admit it, and Python sometimes lags on certain elements like that, but you can do it, definitely. Let me see if I can find a good example of it and link.
So we've got like a minute left here. I'm going to wrap up real quick. All right, so there are a lot of people still watching right now. Thank you so much for sticking until the end.
Cool.
A lot of people, it looks like they probably had to bow out, which is totally understandable, because we went about double the length of either of us thought we would go, which is because you all asked a lot of really good questions. So Kevin, thanks for staying until the end and answering all of those questions. I really didn't expect that. And thanks everyone for sticking around and asking those. Next week, I'll be doing my generators chat. Just a reminder, Kevin, I can't remember whether we plugged your newsletter or Data School. I know we plugged Data School, but you can click the green button. I think it's below the video
Yeah. Yes. It is right below the video.
Cool.
It says subscribe to the Data School newsletter. And you just have to fill out a form and click join, and then like click, you go to your email and whatever.
Right.
But I promise you it is worth it. All right. Do it
And
today.
for those seeing the chat, I just
you will
threw a
not
link to
regret
Weekly
it.
Python chat in there as well. For anyone who didn't get the email, I'm pretty sure if you signed up for this, you got an email asking you if you wanted to sign up for my newsletter. If you do want to, you want to find out about future chats, click the confirm button in the email, or go to Weekly Python chat and sign up yourself. So Kevin's newsletter, that little green button down below the video, mine over in the chat on the whatever side. I don't know where I am in the video, but we have 20 seconds left. So thanks a lot, Kevin. And thanks everyone for showing up. See you at some point in the future.
Thanks, Trey.
See ya.
This is fun. It's really fun. Thanks. Bye, folks.